in Statistical Rethinking, uh, the second edition, and we are finishing up Chapter 8 here. So we'll go through the last three hard questions, H8, 8H5, 8H6, and 8H7. Okay, so all three of these deal with a data set that's part of the Rethinking package that's called Wines 2012. So, by the way, make sure that before you do any of this that you've installed and loaded the Rethinking package with these first two code blocks at the top of the Colab sheet. So we're going to do some things with this, and so I'll just march through it rather than reading all of the questions. Okay, so but you should read the questions obviously for yourself. So the first thing we want to do is we're going to pull up the wines data set and just kind of get a sense of what it looks like with the str command here. Okay, and so we see that we have different judges named, the flight, and the flight is either a red wine or a white wine. And then we have an identifier for the wines here. We have the score that the judges gave and whether that wine was American or, and also whether the judge was from America or not. So I believe that this is like New Jersey and French wines and judges. So anyway. Okay, so the question here asks or suggests that we standardize the data, and so that's what we're going to do here. So I'm going to standardize score, okay, and then I'm also going to take these individual judges here, and I'm going to just turn them into integers so that we can enter them into our regression as a index variable. Okay. Okay. So we've added these to our data set. Now, we're also asked to justify the priors that we're going to use in our model. I haven't told you what our model is just yet, but just based on the force of our prior experience, we've standardized our variables, and so I'm going to use values like 0 and 0.5 for the parameters. Okay, so in this first model here, we're trying to model the standardized score based on the identity of the judge and the identity of the wine. Okay, and that's all we're doing. And so again, you see my priors here. Okay, and so I'm just going to run this, and then we can look at the summary output. But as we go along here, it'll be easier to plot the summary output. And so just to get familiar with this, so we have the Pressy summary function here. And if I plot it, then I get something like this. Okay, so what is going on here? So along the x-axis is the parameter estimates. Notice it goes, well, it's on a standardized scale here. Okay, and then along the y-axis we have all of the parameters. So the first, what do we have? 9 are the judges, the judge identifications. Okay, we have the wine identifications 1 through 20, and then we also have sigma, the standard deviation of our estimate. Okay, so and so we have a vertical line going through 0, right? So that means no effect, and then we have the markers on kind of dispersed around 0. So the little circle represents the point estimate of the mean estimate of the Pressy output summary, and then the bars here represent an 89% credibility interval. Okay, and we could adjust the size of the credibility interval, but it's just that 89% is the default for Pressy. Okay, so it's not real easy to discern many patterns here, but let's try. So if we look at the first 9 rows here, I'm going to blow this image up for us. Okay, so if I look in the first 9 rows here, these are the judges. So we see quite a bit of heterogeneity amongst the judges, and I guess that's maybe okay. We expect different judges to have different tastes or preferences, so that seems okay. And then if we go down here to the wines, most of the wines are middling to fair, and there's a few maybe exceptional ones. So it seems like wine 18 is not doing great, okay, across all of its judgments from all of the judges. And then we see maybe a couple of good ones. So maybe wine 4 and wine 20 are doing well, that these are generally being judged favorably. Okay. So now that brings us here to question 6. And now we are no longer considering individual judges or individual wines. What we are curious about is these 3 features of any particular judgment. Okay? Whether the wine is red or white, and that's encoded as flight. Whether the wine is American or French, and so this is just encoded in a variable that is has a 1 for American, 0 for French, and then similarly for judges. So not the individual judges, but the nationality of the judges. So now we're going to try to model score, the standardized score, based on these variables instead. Okay, so first we need to, so it tells us that we can use either indicator variables or index variables. So an indicator variable, for instance, would be, if I, let me go back up here where I have the structure of my data, right? So I have wine American, and it's 1s or 0s, right? And judges are 0s, for instance. And so an indicator variable would be, if the wine was from America, then I would have, then the value for that variable would be 1, and 0 if it was from France, right? And so, so the coefficient for wine here would only apply to American wines. Okay, so that's what an indicator variable is. But I'm going to use index variables for lots of reasons. They are better when looking at the posterior distribution, and I won't go into that here just for time's sake. But if I'm going to use these as index variables, I need to create some new variables here. Okay, so I'm turning flight. So flight is a factor. Okay, and so I need to turn it into an integer so I can enter it into my regression. So I'm using the if-else command, and so if flight is white, it gets a 1. And if it's a red wine, or in other words, not white, it gets a value of 2. Okay. Now for the American judges and wines, so these are currently encoded as 0 and 1, but I can't have a 0. I need to have values greater than 0 to index on it, and so I'm just going to add a 1 to each of these, right? So now 2 means that the wine or the judge is from America, and 1 means that the judge or wine is from France. Okay. So I'm going to create my model here. So again, I'm regressing standard score onto some things. And so what am I regressing it on? Well, I'm regressing it onto the effect of flight, the effect of the wine, and the effect of the judge. And I enter each of these as the index variable that we just created, right, from up here. Right? And so again, we have our priors here that are similar to before. And I'm just going to, okay, something broke. Give me just a second here. Okay, back up and running. Okay, so let's kind of try to dissect this Pressey plot here. Okay, so we in fact, let me open this in a new tab. Okay, so we have the effect of flight. Okay, and again, one is what is it? One is red. No, 1 is white. 2 is red, I believe. Okay. And then we have the effect of wine. So 2 is American, 1 is French. And then the effect of judge, again, 2 is American, 1 is French. Okay, so we go along here, and so if I compare, say, flights, okay, there doesn't seem to be much preference for red or white. Okay, so that's interesting. If I look at American versus French wines, it seems that French wines are maybe preferred a little bit more than American wines, but they are heavily overlapping in the posterior distribution. And then in terms of judges, it seems that maybe French judges are a little bit more harsh than American judges. Okay, so that's maybe how we might look at that. You know, the things that we're trying to glean from this will depend on, again, the questions that we come into this with. Well, anyway, so that's interesting. If I really want to make good comparisons between, you know, the two levels of either flight or wine nationality or judge nationality, a better way to do that is to draw samples from the posterior and plot the contrasts. Okay, so that's what we're going to do next. So so first I'm going to draw some samples, and then I'm going to compute my contrasts. What are contrasts? Contrasts are just simply one value minus a comparable value, right? It's just the difference between these values here. Okay, so for instance, for judge difference, I'm going to be computing the difference between American and French judges, right? So rather than trying to rather than comparing the difference by just comparing these two lines here, or these two estimates, I'm going to compute the estimate of this line minus this line, or this line minus this line, same thing basically. And so roughly what I'm going to do is I'm going to have a posterior distribution for both of these coefficients, and I'm going to randomly select a value from this line and randomly select a value from this line, find the difference, plot it, and then I'm going to do that 10,000 times or 1,000 times or however many times. And then what we get is a posterior distribution of the difference between the two levels of each of these. Okay, so so let me go ahead and plot these. Okay, so so here I have the difference between red and white wines. Okay, and there's not much of a difference, and again we already kind of saw that here, very overlapping posterior distributions. Here I have the contrast of American versus French wines. Okay, and again very little difference, and that's more or less seen here, very heavily overlapping. But now notice that there's a larger overlap for judges of the two nationalities, so we expect that this last histogram will be a little bit skewed, and in fact that's what we see. So we see that French judges are scoring a little bit more harshly than American judges, right? So this histogram represents the difference between judges. Okay. So now the question is, does this, well, I mean, this is a question I'm asking, but does this evidence of the difference between judges signify some kind of bias on behalf of the judges, right? So, for instance, are French judges more likely to like French wines than American wines? Okay. So now we can't actually answer that with this analysis, because all that we have is the scores given by the different judges and the scores given to the different wines, without necessarily tracking which judges are judging which wines. I mean, we have that in the data, but our regression, it does not have that. In order to get that, we need to have interactions within our model. For instance, an interaction between not white wines, but between French wines and French judges, okay, or judge nationality and wine nationality. And so that's what we do here in number 7, okay? So, so now we are going to add a bunch of two-way interactions, okay? So we're going to have flight interacting with wine, flight interacting with judge, and wine interacting with judge, okay? And so you can kind of see how I've done this here, okay? It's just some simple arithmetic, and you can kind of dissect it for yourself. I'll show you the values down here in the tables, but let's just kind of look at what these interactions mean. So the flight by wine interaction means that the effect of flight on score will depend on the nationality of the wine, okay? Or you could equally say that the effect of the nationality of the wine on the score depends on the flight, okay? And similarly for the other interactions here, okay? So so again, I encourage you to go through the arithmetic that it took to make these index variables, but the take-home message here is that for either the interactions with flight and wine or flight and judge, we have the flight here, the judge here, and these are the encoded values, okay? So for instance, 3 means a white wine and a judge, or wine that was not American, right? So a not American white wine, or a white wine being judged by a not American judge, or a not white wine being judged by a not American judge. Okay, so and then similarly for the wine judge, this is how that's encoded here. Okay, so now we are going to create our model again. Okay, now the first part of the model is just like it was for model 2, right? It's just this same model as model 2, but now we're going to add our interactions. Okay, so we have the 3 interactions that we just encoded. Okay, and I'm going to just run this, and then okay, give me a second here. Okay, so now we have our big output. Okay, again we have the effect of the flight 1 or 2, wine nationality, judge nationality, but now we have the interactions 1, 2, 3, and 4 as you already saw it encoded for flight and wine nationality, flight and judge nationality, wine nationality and judge nationality. Okay, but this is it's hard to make sense of what's going on here. Okay. And so what we really want to know is with the different combinations of red and white wines and American versus French wines and American versus French judges, what are the implications in the posterior? So in order to do that, I am going to simulate some data. Okay, so I need to make up some fake data here, and so that's what I'm doing here. So I have simulated flights 1 and 2. Wine 0 and 1, judge 0 and 1. Okay, this is just emulating the values that were possible in our data, and then I'm going to look for every combination of those things. And so I'm going to use this expand grid. Okay, and I will get every combination of flight, wine, and judge, and I'm going to create a data. It's creating a data frame that has those, and then I'm just creating my interactions again. Just like I did previously, but using SimDat, the simulated data, rather than the actual data, right? So when I run all of this, this is what I get, right? So I get every combination of flights, wines, and judges, and then I get the encoded value for the 3 interactions that we had. Okay, and so now I'm going to use the link function for the M3 model, the interaction model, using this sim data. And then I'm just going to again plot the posterior distributions for the combinations here. Okay, so let me open this up in another tab here. So I've broken down these names into 3 parts. So flight is capital F, and it's either red or white. And then I have wine, not American or American, NNA, and then judge, not American or American. Okay, and so we can kind of go through here and look at what the predicted scores would be under these different combinations. And again, depending on what questions we had when we came into this, we can start to kind of come up with some possibilities. So one question is, are the judges maybe biased for the nationality of the wine? Like for instance, are French judges more likely to favorably score French wines? Okay, so if we go through here, it doesn't seem to be the case. So just as an aside, we could manipulate this posterior a little bit more to answer that question more precisely. But if we look at this, so we want to go to non-American judges, so that's here, okay, and then to compare that to non-American versus American wines, okay. And so if I go to, for instance, if I go to this guy, so a non-American judge judging a non-American red wine, and then here, a non-American judge judging an American red wine, okay? We see that there may be a little bit of a discrepancy. But then if I do the same thing for the white wines, that flips. The preference seems to flip, okay? And then you see similar phenomenon with the American judges. So it doesn't seem then that there is, given this, it doesn't seem that there is much of a bias. Now again, what we could do is, and maybe should do if we were trying to ask this particular question, is compute the contrasts of the appropriate contrasts of, okay, do French judges tend to judge French wines better than American wines or something. But anyway, I think that's as far as the question asks us to go. Okay, so that's it.